Hey friends, welcome back. Today we will see income prediction on census data, and this analysis is going to be based on Niave bias algorithm, which is an algorithm of supervised learning. So this is the objective that to predict whether income exceeds 50k per year based on census data. So this is the context of data that we have. You can also check out this link and get the description. The same is there, right? I have written here as well. Now let's start with importing our libraries first. So first thing, importing pandas and numpy libraries, and second, for importing imputer and pre-processing from sklearn for pre-processing of the data. Next thing is importing train test split for the splitting the data into train and test data set, and then importing the Gaussian Niave bias to get the model, that the Gaussian Niave bias classifier. And next thing, to calculate the accuracy score of the model, and that is importing accuracy score from sklearn matrix. Now what we are getting is we are reading the adult data, that I'll provide the data link in the description as well, and the files, and getting the adult df, right? Header getting none, delimiter we are replacing that, and engine, that is of course Python. And what it will do is it will load the data set. Observe that this file has data extension, right? So for importing the census data, we are using pandas that read csv method. This method is very simple and fast method for importing data. Yeah, so we are passing our parameter, that is first is the data itself, right, which is the file name, and the header parameter is for giving detail to pandas, that whether the first row of the data consists of header or not. In our data set there is no header, so we are passing none. Okay, next thing is the delimiter parameter is for giving the information, the delimiter, that is separating the data. Okay, here we are using comma, you can see that, and comma delimiter. So this delimiter is to show, delete the spaces before and after the data values. You can see that the comma, space before and after, right, of the values. And this is very helpful when there is inconsistency in space used with the data values. So we are printing the column in the adult data set. So adult data df dot column, so this is 0 1 2 3 4 up to 13 14 d type, and where it is integer. Now checking the or adding headers to the data frame. So here you can see that adult df dot column, so this is the column that we are additionally adding: age, work, class, right, educations, final weight, educations, education number, so on so forth, and income. And next thing, we are getting the number of records in rows. So here you can see, if you check the length of adult df, so it will be 325661, right? Now handling missing or imputing the missing data. So test whether there is any null values in a data set or not. We can do this by using isNull.sum. So you can see that every sum is 0, so it will, that means the above data, there is no null values in our data set, right? And let's try to test whether the categorical attribute contains any symbol like this, right? At times there exists this symbol or this symbol in place of missing values. Using the blow code snipped, we are going to test whether adult df data frame consists of categorical variables with values, this symbol of the question mark. So checking this in the loop, so for value in all these column name that we wanted to check, right? Now printing value. Okay, printing value, what it will be if the adult df value is question mark. So if any value in the adult df, right, is question mark, just return that column from these columns. So in work class we have 1836, in occupations we have 1843, and in native country we have 583. So the output of the above code snipped shows that there are 1836 missing values in work class attribute, so 1843 missing values in occupation attribute, and 583 values in native country attributes. Now let's move forward to the data pre-processing part. So for pre-processing we are going to take or we are going to make a duplicate copy of the original data frame. We are duplicating adult df to adult df new or revw, whatever you call data frame, and observe that we have used deep copy while copying. Why? So deep copy of adult df, so there you can see that we are getting the copy, right, where deep is true. So before doing missing values handling task, we need some summary statistical of our data frame. For this we can use describe method. It can be used to generate various summary statistics including none. So before doing that, yeah, here the deep is true. Why? Because the data will be copied, but the actual Python libraries will not be copied recursively, right? So that's why we use deep equals to true. So now describing the data, again we are getting mean, count, standard deviation, minimum value, maximum value of all these column, age, final weight, education number, capital gain, capital loss, hours per week, right? So here you can see that we are passing an include, right, parameter with value as all. Okay, and this is used to specify that we want summary statistical of all the attributes. Hope you remember that here we give like include equals to all, right? So this will specify that we want summary statistical of all the attributes. Now adult df rev dot describe, yeah, this way, this is what I was talking about. So here we have given include equals to all, so you can differentiate. Here you got the unique extra, the frequency extra, top extra, right, mean extra. So this way mean was already there, but yeah, these 2-3 value will get extra in including all. Now going to the next part, that is data imputation. So some of the categorical values have missing values, that is question mark. So we replace the question mark with the above describe method top rows value. For example, we replace the question mark value of workplace attribute with private value. So for value in these columns, right, replace value will be our adult df new dot describe, that will include all value 2, right, second value, and adult df rev of value of adult df rev value equals to question mark. That means if the adult df rev value equals to question mark, then take this value and replace this value with this one that we got from here, right? So for Niave bias we need to convert all the data values in one format. We are going to encode all the labels with the value between 0 and n classes -1. In the present case it will be 0 and 1. For implementing this we are going to use label encoder of scikit-learn library. So here you can see that we are doing hot encoding where le equals to preprocessing dot label encoder, work class category, that we are getting le dot fit transform. Then education category, we are doing le dot fit transform for education. Similarly material fit transform for material status, occupation fit transform for occupations, relationship category fit transform for relationship, race categories, right, gender category, and native country category is also there. Now initialize the encode categorical columns. So if we work to encode it, so you can see that we are replacing the old work class categorical with this work class categorical, where we have fitted the transform, right, where we have fit transform of adult df or workplace. So same way we will do that with every category or every attributes. Now adult df ref dot head, if you get that, you can see that the slight difference of your income. here you will see that we have added the income based on these values, right? So if you check this, the income is telling it is less than equals to 50k, less than equals to 50k, like that, right? So there are total 5 rows, 23 columns. Now dropping the old categorical column from data frame, so dummy fields that we have all these column, and adult df rev, that adult df rev dot drop all these column, and this will be dropped this one for the column only. Now rendex all the columns properly. We have passed the list of column names as a parameter and access equals to 1. For reindexing, the column will be what? So adult df ref equals to this value access, and we are again passing all the column, right? Access equals to 1 and getting the head of all these value. So here you can see that this is now reorganized, where we are getting income at the last as well. Now we have created multiple categorical columns like material cat, race cat, right? You can see that everything is differentiated. Next part is for data slicing. So we arrange data into independent variable and dependent variable. Hope you remember that. So for feature and target, feature is x, target is y. So feature will contain adult df rev values 0 to 14 or 0 to 13, right? And this is the features value we have from the adult df rev, and these are the target value we have in y from adult df rev. Now splitting the data into train test. So here you can see that the test sizes we have 30%, and that means the train sizes we have 70%. So x train, y train, x test, y test, right? Train test split xy, test size equals to 0.3, random state equals to 10. Now we implement the Gaussian Niave bias. So how? The CLF, we are defining a variable taking the Gaussian bias Niave bias function, and CLF dot fit equals to x train, y train. Now Gaussian is priors none, variable is smoothing LE09, right? So here the Gaussian classifier is built by using this CLF dot fit function, right? CLF is our Gaussian Niave bias, and in fit we are passing x train, y train. So the classifier is trained using training data. We can use fit method for training it, right? After building a classifier, our model is ready to make prediction. So we can use predict method with the test set feature as its parameters. So y prediction will be CLF dot predict x test, and accuracy of our Gaussian Niave bias model. Okay, so accuracy score, if we check that y test, y prediction, and normalize equals to true. So after getting our model, if we check the accuracy, how accurate it is, so it is around 80%, right? Although 79%, but yeah, this slide good, right? We have implemented our Niave bias for income predictions, okay, of the census data. So yeah, we got result, but the accuracy also matter, how the accurate our model is on the basis of that train test split. Okay, so this was all about this video. I'll come up with another examples as well. Stay tuned. All the best. Thanks.